Okay, so we're going to split 6.4 into 3 days. So this first day, we're just going to look at how you can use vertex form to talk about the optimal value in a parabola or the maximum and minimum value. And so that is going to be important for when we do 6.5, which is the word problems. Okay, so here we have, it says, state the maximum or minimum value state the maximum and minimum value and which value it occurs, and graph the parabola. So we'll review that a little bit as well. Okay, so you always need two things. We need the vertex and we need the step pattern. So here the vertex is, remember, this is always the opposite. So this would be left, or -5. And then this is down 2, so that's -2. And then the step pattern is influenced by the A value. And again, if you can do this in your head and you don't need to show that this in between step here, that's totally fine. Okay, so our vertex is -5, -2. It is opening down, and it's 2, 6, 10, so modified. Okay, so over 1, down 2, over 1, down 1, 2, 3, 4, 5, 6. We're not even going to get to 10, which is fine. So now so that's the graph, that's I. So then if you're looking at the optimal value or the maximum or minimum, so this is a maximum value. It's the biggest. At the maximum value is, and we say the maximum value is -2 when x equals -5. Okay, so one of the reasons that we do this is because often, and you're going to see this again when we start to do the word problems, usually the y-axis is the one that you're measuring, right? That's going to be the independent variable, or the dependent variable, sorry. So then when like profit or distance or area, right? So after you have made some kind of measurements, what's this value going to change into, or what's it dependent on? And you can also think of it too that even though the vertex technically is -5, -2, if you look, then the values for x can sort of be changing. So we usually say the maximum value is -2 when x equals 5. Sometimes it'll even say the maximum value of y is -2 when x equals 5. And again, once we get to 6.5, you'll see that the y values might actually have meaning, like profit or area, things like that. Okay? But it's going to be basically the same thing every single time. You're always going to say, like, you can, if you look later on in the lesson, the whatever maximum or minimum value of y is when x is, okay, so we're going to frame that answer the same way every single time. Okay, so let's do the same thing. We got to make the graph, so we need vertex. So here now this is to the right, so 5 and then up, so +5 and +9. And the step pattern this time is -1, -3, -5. So down again. So over 1, down 1, over 1, down 3, 1, 2, 3. Oops, I did too many there, sorry. Over 1, down 1, 2, 3. Over 1, down 1, 2, 3, 4, 5. Over 1, down 1, 2, 3, 4, 5, 6, 7. Over, down 1, 2, 3, 4, 5. Sometimes it's easy to see the symmetrical points. Sometimes it's not. And remember, do a better job with your pencil connecting the dots. It's hard on with this Apple Pen. Okay, so now, actually, I'm going to label that. That's A and that's B for when you go back and look at your notes later on. Okay, so now again, we have a maximum value. So I'm going to write the maximum value of y is positive 9 when or at x equals positive 5. So really, yes, you can use the graph to figure that out, but also we can use the vertex as well. So the vertex is a very important value. Okay, so it helps us with these optimal values. And you're going to see that over and over again. So like I said, moving forward, when we do 6.4, we're going to look at a different way to find the vertex form. It's a very useful form of the equation. And like I said in the other lesson, if you were given, if this was a real, like if we were really in class, you would be given this, given on a test, given on exam, the whole lot. Okay? Okay, so we're going to do these ones. So, now we have vertex -6 and -10. So this is left and this is down. Okay, so again, if you're given a grid, then your parabola should fit. So that's a good chance. Oh, if we're way down here, we're probably not going to do a parabola like that because it doesn't fit on the graph. Okay, so but this time it is up, but it is modified because of the A value. But this time it is positive, so it's going to be opens up. So over 1, up 3, 1, 2, 3, over 1, up 1, 2, 3, 4, 5. I don't know. Over 1, up 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12. Nope, can't fit. Oh, sorry, not 5, 9. Over 1, up 1, 2, 3, 4, 5, 6, 7, 8. There we go. So there's no way we're going to get 15 on there. So let's parabola C. So again, now we have, this time we have a minimum value of y is -10 when x is -6. So here we have a vertex of, so this is right, sorry. Oops. I started to write it and then I changed it. So this time you're going to go right 3, but there's no value outside there. So back to the base value of the vertex, which is 0. And then the step pattern also isn't changed. It's going to be 1, 3, 5. Over 1 and positive. Over 1, up 1. Over 1, up 1, 2, 3. Over 1, 1, 2, 3. Over 1, 1, 2, 3, 4, 5. Over 1, 1, 2, 3, 4, 5. And again, if we were going to answer questions about the y-intercept. If you wanted to check your answer, you would have to expand that out and FOIL it out to get it to standard form, which this question isn't asking us to do. So that was the last lesson. We don't have to worry about that. Okay, so now again, this is D. We have a minimum value of y, which is 0 when x equals 3. Okay, and then the question down here, what does you discover about the minimum and maximum values? So the A value, if it's positive, that means you're going to get a minimum, sorry, goodness. And if it's negative, you're going to get a maximum value. And then Q tells you the optimal y value. And P, the optimal x value. Okay, but really, like you can use the vertex, okay, to help you. So that's why vertex form is really so important. Okay, so and here's another slide with the summary. Okay, so if A is positive, then the parabola opens up and you get a minimum value, and then the x value of the vertex, and this is the y value. And then if it's negative and it opens down, then you get a maximum, and then the maximum is x equals -6, and then the maximum y value is that value outside there, okay? Because here, this vertex would be -7, -12, and this vertex would be -6 and +9, okay? So you can use that to help you. All right, so write the word minimum or maximum and data from each graph or equation to complete the following sentences. So A and B are just equations, and then you can see here C and D are actual parabolas. So if it's a positive A value, then that means that we are going to have a minimum. And if you just want to write min and max, that's totally fine. So the minimum value of y is 20 when x equals 12. And here we have a negative, so this is going to be a maximum. And this time it's going to be 17. So this value is the y value, and then this value is the x. When x equals -3, but remember the x value is the opposite sign. So in C, we have a maximum value of y is 3. It's a bit blurry, but that's a 3 when x equals -6. So I'm just looking at this point here, the vertex, and the vertex is at -6 and +3. And then over here, now that's a minimum value when y is -4, when x is +4. So I just read it off the graph. Okay, one last type of example you could have to do, determine the equation of each parabola in the form, so this is again vertex form. Okay, so the vertex is 0 and 5 and passes through the point -3 and 11. So this is, teachers love this question. So sub in P and Q from the vertex. So we have P and we have Q here. So we're going to sub it, because we want it to be in vertex form, we're going to use the base vertex form. Even though 0 doesn't change it, I'm just going to leave it in there for now, okay? So sub in P and Q from the vertex, And then, so that's step number 1. Then we're going to, basically we need to solve for A. But we still have this y and x, right? We have too many. So how can we solve for A? So then sub in x and y from the point. Actually, I'm not even going to label that number 2. So this is x and y. So y is 11, x is -3, and then you're going to solve for A. By like simplifying, maybe you have to FOIL, simplify, collect like terms, whatever. So that was -3. Oops. -0 is just -3. -3 squared is 9. So I'm going to bring the 5 to the other side. It doesn't really matter which side the variable is on. So I'm going to bring the 5 over. So 11 minus 5. I'm going to rewrite that like you're used to. So 6 equals 9a. And then we need to divide by 9. Now, you can do 2 things here. You can change this into a fraction, or a decimal, sorry, or you can leave it as a fraction, but make sure you reduce, okay? If you want to use, if it doesn't say to graph, then maybe then you can have a weird fraction. I wouldn't make you try to graph this parabola with this weird a value, okay? So sub in and then simplify, and then step number 4, use A, P, Q in vertex form. Okay, so now we have our A value is 2/3, x minus P is 0, plus 5. And you know what? You can even just leave it like that, okay? So we're going to do the same thing. Oops. But this time we're given the y-intercept, which is no problem. So now the y-intercept means that when x is 0, then y is 16. That's the y-intercept. So here we have PQ, we still have XY, so we're going to do the same steps. So sub in P and Q. And remember, when you do this, then that's minus -4 squared, which you can simplify. Then we're going to sub in the y and the x. And simplify. Now, if you want to, that's easily written as 0.5, that's fine. And then step number 4, use your A value and your P and Q to write the equation. Okay, so there's the homework there. Again, we're sort of kind of practicing over and over the same steps, so give those questions a try.